welcome to the deep dive. Today, we're looking at something pretty cool. How seemingly abstract math connects to, well, very real environmental issues.
That's right. Specifically, we're digging into some sources on forest resources technology.
And seeing how math concepts, things like differentiation and integration, actually help us understand something like soil erosion.
Exactly. The mission, you could say, is to unpack how these tools aren't just textbook exercises, but vital for managing our natural resources, like
Yeah.
understanding how the land's shape affects soil health.
Okay, so let's break down the core math ideas mentioned in the material. First up, differentiation.
Mm,
Basically, it helps us grasp rates of change, right? Like how fast something's changing at a particular moment.
precisely. And then you've got integration.
Right, which is more about accumulation, summing things up over a range to find a total amount.
Yes, exactly. And what's really fascinating in these sources is seeing these concepts applied directly, in the forest. Well, they focus specifically on the link between soil erosion and how steep the ground is the slope gradient.
Okay, that makes sense. Steeper slopes, potentially more erosion.
Mhm.
We kind of know that intuitively.
We do. But the math, specifically differentiation here, lets us measure that relationship with real precision.
Ah, so this is where differentiation really comes into play,
Yeah.
according to the sources, measuring the sensitivity.
Exactly. That's the key term they use. Sensitivity of soil erosion to the slope gradient.
So it's answering the question, if the slope changes just a tiny bit, how much more soil washes away? Or maybe less.
Precisely. Differentiation gives us a way to quantify that exact response at any given point on the slope.
And knowing that sensitivity, that specific rate of change, why is that so crucial?
Well, think about managing a forest. It's not enough just to say steep slopes are risky.
Right.
Knowing the sensitivity tells you how risky. It might reveal, say, that erosion doesn't just increase steadily with slope. Maybe beyond a certain angle, like 15 degrees on a particular soil type, the sensitivity analysis shows that the erosion rate suddenly accelerates. It jumps up dramatically for each extra degree of steepness.
Wow. Okay. So it identifies critical thresholds,
Exactly. That specific measurement lets forest managers pinpoint the slopes where even a small disturbance could trigger major erosion.
which then directly informs decisions, I imagine.
Yeah.
Like where it's safer to build a road or harvest timber or
Right.
where you absolutely need things like terracing.
Absolutely. It guides those practical conservation and land use strategies. You move from sort of general rules of thumb to very targeted data-driven actions.
Without that differentiation, without quantifying sensitivity, you might just lump all steep slopes together.
You might, and you'd miss those crucial points where the risk really escalates. It allows for much smarter, more precise management.
Makes sense. Now, we also mentioned integration. How does it fit into this picture? Differentiation is the rate, the sensitivity.
Right. And while the sources seemed maybe more focused on differentiation for sensitivity, integration definitely has a role.
Okay.
If differentiation gives you the rate of erosion at points along a slope, integration could let you sum up those rates over an entire area.
Ah, so you could calculate the total volume of soil lost,
Yeah,
like from a whole hillside or watershed over a year.
exactly. You'd integrate the erosion rates across space or maybe over time to get that cumulative picture, the overall impact.
So there are different perspectives on the same problem rate versus total amount.
Complementary tools, both incredibly useful for understanding the full story of erosion.
So this is a really clear example then, whether you're interested in environmental science, maybe engineering, or just curious about how the world works.
Yeah.
These math concepts, differentiation, integration, they're not just abstract classroom stuff. They're absolutely fundamental for getting a handle on complex processes like soil erosion.
And for making informed decisions to protect the environment. It really shows how essential applied math is for tackling, the big environmental challenges we face.
Absolutely. It's quite powerful when you see it laid out like that.
After.
And it kind of leaves you wondering, doesn't it? This idea of sensitivity, precisely measuring how one thing changes in response to another. Where else is that critical?
Good question.
Beyond slopes and soil, where might this concept be revealing hidden connections, hidden dynamics in the world around us, maybe in economics or biology? Things we don't immediately connect to calculus.
Yeah, how changes in one variable can have disproportionate effects elsewhere. It's probably everywhere, just waiting for the right tools, the right analysis to bring it to light.
Something to think about.